today. Then we're gonna back up to our TEKS activity that we were doing the day before and finish that up. And I want both finished today before we leave, so that Monday we start with new stuff, okay? All right, so volunteer for the next group. Let's just do this one back here since y'all are close. Wait, he's still eating. Let's do this one over here. And there's wires everywhere, so be careful. I need the groove. And y'all had which pattern?
5.
Pattern number 5, which is the top pattern right there. Okay? So, one of you needs to talk.
Okay, this is our picture.
Okay?
This is our T-chart. So this is the X, which is the shape number. And this is the Y coordinates, which would be the number of tiles, total tiles. Okay, number 3, this was our graph. We have our independent, which is on the X-axis, and that's the shape number. And then the dependent would be the number of tiles on the Y-axis.
Could you read some of your numbered pairs out to us, please? Number 3.
The first coordinate that we applied would be 1, 5.
Okay?
And then we went to 2, 10. And then we went to 3, 17, which threw us off because we couldn't figure out a function after that. Yeah, that was disastrous. But we finally figured it out.
Let's back up. Because you had 5 in the, I'm looking at the Y coordinates. Y coordinates. You had a 5 and you had a 10. Were you expecting the next one to be a 15?
We were hoping it'd be that easy. And it was not. And so what we ended up doing, because Dr. Browning helped us, is
No, I did not. I just asked you a
she
question.
led us to finally figure out what was going on because it was not happening. And so she took away the extra on each end where it looks like a Z, and you end up with, you know, a rectangle. And so the first one is a rectangle with the length of 1, and then this is 2, and then this is 3.
What's 2?
Sorry, the length for the second one is 2, and then the length for the third one is 3,
Okay.
and it follows that pattern.
What are the
What was throwing us off was the extra 2. We didn't understand what to do with that.
Before the 2, what were the heights?
The heights, you had 1 by 3, and then you had 2 by 4.
Wait, one what by 3 what?
Sorry, 1 square by 3 squares, and then 2 squares by 4.
You mean the length was 1
Yes.
and the height was 3?
Yes.
Okay, and so for the next one?
The length was 2, and then the height was 4. The length was 3, and the height was 5.
Good, and that was an important part.
Yeah.
Go ahead.
Okay, so once we figured out to not worry about the extra 2 yet, we decided that we would take the shape number, which is also the length, times the shape number, or the length, plus the 2, times that together, and then you add an additional 2, which are these extra guys.
Yeah, I'm not real sure when you said times that together. I'm not-
Sorry, you do x, which is the length, plus 2, and then multiply by the length again, x, and then add 2, the 2
Okay.
extra guys.
So what you're telling me is, I think, that you found the area of the rectangles with those 2 Z-looking things removed. Okay, so the length of each of those was equivalent to the shape number?
Yes,
And the height of each of those, how does that relate to the shape number?
the height was the shape number plus 2, which is where we got the x plus 2.
Okay,
So we basically did length times height
okay,
plus 2
okay, and that plus 2, or which 2 up there?
are the 2 additional that make it to the Z pattern.
Okay, so the one on the bottom sticking to the left and one on the top sticking to the right.
Yes.
Okay, all right, go ahead.
And so that was how we found this, and then our sentence is the shape number plus 2 times the shape number plus 2.
Is, that's not a complete sentence.
It was complete. Is our function,
No?
is y,
Is equal to what?
e is equal to y.
Is equal to the number of tiles or
Tiles.
squares or whatever you
Okay.
say. It's equal to the number of tiles. Okay, you have to have a complete sentence. Where, can I ask y'all, where in an equation is the verb? If I have x equals 3, where's the verb, not Eugene?
What's a verb?
Equals.
The equals, exactly, is equal to, that's the verb. So if you have a complete sentence, you either have to have something is equal to something, something is greater than something, something is less than something, something is equal to or greater than, you know, those things, okay? So what she said before, that is, when she added the is, that was not a complete sentence. What do we call that in English? A fragment or a clause or a phrase, something, but not a complete sentence, right? Okay, so when I say I want you to write something in a complete sentence, it's got to have a verb in it. And the verb in the equations is the equal. It is equal to, that is the verb, all right? So you can tie that, next time those writing ladies come in, you can tie that to that, okay, as part of your writing. Yes, dear?
What was the question that you asked to help guide them? Because this is something that the kids in Elmsville struggle with, because it's a two-part sheet.
Yes. I don't remember the exact
But
question
I'm
I asked them.
just fishing for what,
Right.
how you approach it. You did knock the two off.
And yes, we knocked the 2 off, and then I asked them what shape is that,
Okay.
and how would you find the area of that?
Okay, so that was
And then
kind
it's,
of.
yeah.
So do you
All right,
kind
no,
of
that's
just
good,
tell
I
them
like that. I mean, I
to
just
focus
like
on
the,
the,
what's similar about it, we got two tiles on each side, remove those tiles.
Yes.
What you-
Yes, and you would phrase it, depending on your grade level.
Right, right.
You would phrase it in what stays the same and what changes, and those 2 stay the same. So let's
Right.
ignore those for a while and talk about what changes.
Yeah, I like that, that's a good one.
All right. Yes, ma'am?
I was gonna ask you something.
Okay, yes, sir.
Is looking at the, I'm not sure if this is the right word, the differentials, is that a trick, or is that a way?
That is
for-
not a trick, it is not something you would do in 5th grade and they teach 5th grade. Yeah, but it is not a trick, it's a good skill. But we're not gonna do that right now.
Differential equation?
Yeah. No, I've forgotten what the term is. Tim, that term, when you take it out.
Okay, what
Thank you, Tim. When you're looking at. It's smart, you know?
I'm trying to make this, gonna get killed or something.
All right, let's get this answered. When you're looking at the Y values, oh, finite differences,
Finite differences.
finite differences. Thank you. Okay, very nice. Very nice.
I was confused for real, I wasn't.
I'm sorry, I thought you were smart aleck. Okay, let's go ahead and do the next group that's up there next to Brenna and Tamara's group, okay?
Hey, you're in my group.
Yes.
Oh, she's a silent partner.
Yes, she is.
I know.
She's there for support, Lisa.
Hang on, I gotta find the chair.
I'm sorry.
Hang on, I gotta find the chair before I get up.
And which one did you do, Lisa?
We had, number 4, number
Number?
of line segments.
With 4 down at the bottom there on the left.
So, because I know she's gonna get me for all this. So for our. That's why I don't want you candy while I'm talking. So for our picture, we did the same that we had here, but we went ahead and did an extra so that we would know.
An
I'm sorry?
extra what? An extra what?
We created an extra shape so that we would know what the pattern continued as.
Okay.
And then we went through, and for X, we have the shape number,
Okay.
and Y is the number of line segments.
Okay.
So for our first shape, we have 4 line segments.
Okay.
And for our second, we have 7 line segments.
Show me, come up here and show us where those 7 are.
You have 1 here,
Uh-huh.
2,
Mhm.
3,
Mhm.
4,
Okay.
5, 6, and 7.
Okay, thank you. I just needed to know if you were counting that top one that goes from 2 blocks as 1 line segment or 2 line segments. Okay, you counted it as 2.
Yes. So then for the third one, we have 10 And the fourth, we have 13.
Okay,
And the fourth shape, we have 16.
which one?
I mean, the fifth shape,
Okay.
we have 16 line segments.
Okay, good.
So our function is, we said in,
For, you said in, I said.
oh,
I
for
in,
number, the shape number,
For the shape number,
Mhm.
okay, you're using in for your variable,
yes.
okay.
And then we have, for the number of line segments, we have 3n plus 1.
3n plus 1, okay?
So, in our graph,
Mhm.
when we graph them, we notice that they all go up in
What's they?
our numbers, or coordinates go up.
Stop feeding her.
Boy, I'm part of this team.
I know. I want Lisa to work through this. I have my reasons.
It goes up,
What?
but the coordinates go up.
The
But what
coordinates
I
go up?
first noticed,
Hang on, the coordinates go up? Coordinates are numbers.
Mhm.
So
or it increased, the
what increase?
number of line segments increased for each shape number.
Better, good.
But when I did that, I had to look back at it again, thanks to my partner over here, Karen, that it went up, but it still didn't, I'm sorry, the number of line segments increased for each shape, but it still didn't meet where our next, I want to call it a point,
You can call it a point.
where our next point is. So I had to go
Wait,
back
wait,
and
what
look.
do- What do you mean it didn't meet where your next point is? What didn't meet? I don't want any ifs.
The next number of line segments, it didn't
Okay, so
correlate.
Point to that bottom point.
I am still lost and confused.
What are the coordinates of that?
That one is 1 and 4.
1, 4. No,
Right.
1, 4. Which means from the origin, you moved what direction?
First, we moved to 1 on the,
You moved to the right,
to the right,
1
1 on the X
axis.
axis,
And
and then
then-
we moved up to 4 on the Y axis.
You moved up 4.
Mhm.
You moved, so you went to the right 1 and up 4.
Right.
And it's okay to call that up because it is vertical
Right.
right now, okay? Then to get to your next point,
Mhm.
what did you do? How did you move?
We moved over to the right 1 more. Because now we have 2 shapes.
Thank you.
And because now that we have 7 line segments, we had to move up 3 more
From,
from the first one,
which was
which was 4.
4. So you moved up 3 from 4.
Right.
Yes, okay?
So that's how we noticed that it was only increasing by 3
Okay.
per.
Are you telling me you
Shape.
noticed it from the graph and not from the table?
No, I did notice it from the table as well, but
It was more visual from the graph?
yes,
And that's,
using the visual is what helped me realize how each of them were,
How it was
how the pattern
changing.
was changing.
And that's important, that some kids will need the table, I'm a table person. Some kids will need the table, and some kids will need the graph. So they're both important, Christine.
Lisa, I heard you say when you jumped from one shape, the first shape to the second shape, that at that point you noticed that it would increase by 3. Shouldn't we then, at that point, question, you noticed it was only one movement, and we can say that for every shape? Right, I mean, shouldn't we question that, because it was one shape movement, can you be 100% accurate that that is what your pattern is going to follow, or
Right,
that's
like-
just the one
If
step?
we had as much time as I would like, I would make her go through that process of moving for
Okay.
every single point before she makes that generalization. Yeah, and that's a great point, Christina, she needs to do that. What were you saying?
along with Christina, because the first group that went, they were under the assumption that it went from 5 to 10, as we were 10 to 15, but didn't know it 10 to 17.
Yeah, that's important. Okay, continue, Mary.
So our sentence is the shape number times 3 plus 1 yields the number of line segments for that shape.
Okay, and so your function?
Y equals 3x plus 1.
Okay, I'm gonna be a little bit picky here, just for the 8th grade teachers here. Read that first, read your verbal description again.
The shape number times 3 plus 1 yields the number of line segments for that shape.
Okay, the way I hear that is the shape number times 3 plus 1, in parentheses, 3 plus 1, which is not correct. Okay, it's just, you're just multiplying the shape number times 3, and then you are adding the 1. So how could you rephrase that, Lisa? Not Karen, Lisa.
I'm not opening my mouth.
Okay. Because she needs to work through this. She's doing a
Yes,
great job.
this
Doing a good job.
is my issues. Okay, the shape number times.
Okay, now what is addition? What do we call the answer to an addition problem?
A sum.
A sum. So could we somehow involve the word sum in there?
Take out time.
Hush, Jesus.
Yes, okay. The shape number,
What did you multiply? the
times
shape number?
3,
Okay. Could you switch that?
yes,
Okay.
I think so,
Could you say 3 times the shape number?
yes.
Okay, then could you say the sum of
The sum of
what?
plus 1.
The sum of what plus 1?
The sum of the shape, or 3 times the shape number plus 1
Okay,
is the number of line segments for that shape.
okay, y'all buy that one?
Yeah.
Better? Good job, Lisa. I tried. Let's look at those 2 graphs that are side by side. Y'all with me? Let's look at the 2 graphs that are side by side. I didn't have that group over there talk about their graph because I wanted to compare the 2, okay? What do those what do those graphs look like they form? They do look like they would form a line, right? If we connected the dots, they do look like they would form a line. So those are called linear functions. Line is linear, that's the adjective for the noun line, okay? So neither one of them connected the dots. I wonder if we should.
I didn't, because if you are at shape 0, there are no tiles.
Okay, so did you go through the origin?
No.
It didn't go.
I didn't think if you had 0 shape, you know, 0, actually it would be less than 0 tiles, right, or 0 tiles. I guess you could.
See, hear how she's struggling with that? It would be less than 0. So is
I
she
mean, if we're
completely
following
wrong?
the
Hang on a
pattern.
minute. Is she completely wrong in her thinking?
No.
No, she's doing a great job of thinking through that. It's not gonna go through the origin, is it? And she knows that somehow. She knows that somehow. So, I mean, she's not an algebra student, you know. So it's good that you're recognizing that, Christina.
I agree with that, it should be connected.
Why?
So from my perspective, if I have y is equal to 3x plus 1, and I'm just plotting that, when I plug in a number for x, I could technically have a 1.5 and I would get an answer.
You could have
However-
1.5 what?
I could have for x, the number of 1.5.
Okay, just the naked number of 1.5.
Correct.
Okay.
If I'm just doing that, and I would find an answer for y and could plot that. However, because we are associating the x with a shape number, unless we're going to start calling it randomly, this is one, this is shape number one, this is shape 1.5, this is shape, there isn't really a 1.5 as a shape.
There's not a one and
There's
a
a
half
whole
shapes?
number, as this is one shape, two shapes, three shapes.
You can
Four.
dissect by
Y'all,
section.
hang on, y'all agree though that there's not a 1.5 shapes up there? Because if we can get 1.5 shapes, we can get 1 1/4 shapes, and we can get 1 1/10 shapes.
Well, they're not on there, but you can make them.
We could make them, okay, so looking at their, okay, which shape do I wanna look at? I wanna look at at Brenna's group shape up there, okay, the top right. How would you get half of that shape? Bisect it, you're going to cut my tiles in half?
You're asking me, yes.
Would I let you cut my tiles in half?
Not if that's part of the original
Yeah.
parameters you gave us.
I would not let you cut my tiles in half. So could you get half of shape 1?
No.
You could not. These are physical objects and I'm not gonna let you break them to make them fit your suppositions, okay? Now, somebody did say on shape 2, you could bisect it and it would be, you know, you could get half of that one. Could you get half of shape 3? No, you have to cut my tiles again and I'm not gonna let you do that. So technically, could we have?
At that point, because I couldn't do that physically, I wouldn't get a Y to be able to plot.
Exactly, you
So-
would not get your Y value.
That's correct, so then that is why I say I agree with them not being connected.
Okay, because you can never have a dot on 1.5 and whatever that would be for your Y value, which is, I don't know what it would be, okay, Margaret?
Is that what you call in algebra discrete?
Exactly, that's what you call discrete data. Those two are discrete data. You would not connect the dots. Now, sometimes in our beautiful, wonderful little world of mathematics where we get to do pretty much what we want to do, whereas unlike science where they have to do what the world tells them to do, we sometimes connect those to make other suppositions or to extend the pattern or, you know, to pretend we could have negative number of tiles, okay? We do connect them sometimes if our focus is now not on